Okay, I think we'll get started. So today we're talking about limiting reagents. This lecture is going to be actually pretty short, but this is definitely a really important concept, and it tends to be one where students get hung up a little bit. So I really encourage you to work a lot of the problems in your whatever general chemistry book that you have surrounding limiting reagents. This will be a very clearly identifiable section in whatever gen chem book you're working through, and just really make sure you work the problems till you have the concept down really well. The idea here is that when we run a reaction, we talked about stoichiometry last time, but it's almost never the case, unless we really carefully engineer the setup, that we're going to have exactly the right amount of reactants so that they both run out at the same time if the reaction goes all the way to completion, such as a combustion reaction. So the chance that just at random we have exactly the same amount of, or the right amount of oxygen to completely react with all of the benzene in this case to form carbon dioxide and water, so that nothing is left over out of these, is an important. Is unlikely. So it's important to know how to handle the more typical case when there is a so-called excess reagent. Now, in this case, we're saying 100 grams of benzene is burned in excess oxygen. So here it's identified for us that the excess reagent, oxygen, and the limiting reagent is benzene. And then we can just go about our business calculating the way we've learned how to calculate. Now, we might be in a situation, though, where it might not be obvious which is which in terms of the limiting reagent and the excess reagent. And so we have to go about the work of identifying that. So let's take a problem where we're told 72.5 grams of benzene is burned in 216 grams of oxygen, and we want to figure out how much water is left over. Well, how we do this in a kind of a systematic way is we cannot compare grams to grams. So we've talked about when we have a reaction stoichiometry, it's always talking about moles. And even there, we cannot compare moles of benzene to moles of oxygen. We have to get all to one or the other. And so you just choose one. Let's cast both the benzene and the oxygen of what we've been given into moles of benzene. That's just our choice. We could have done moles of oxygen. And in this case, when we do that, we were going to compare the moles of benzene that we get from this many grams of benzene. So that's simply a grams to moles conversion. And that's done here to give us 0.982 moles of benzene. And from here, which is the 216 grams of oxygen, so here we need to convert oxygen to moles of oxygen, and then use the stoichiometry as a conversion factor here to convert moles of oxygen to moles of benzene. And we get 0.900. And so this tells us that the limiting reagent here is the oxygen. That's what is the 16.16 grams, or 216 grams of oxygen. And the excess reagent is benzene. Okay, now we might be asked, well, how much water have we produced? And in this case, we have we work with this, right? Because this is all the benzene that we can consume. We can't use this because that's more than what the oxygen is able to react with. And so we have to use this number as our determinant here. And so we can then readily convert that to grams of water. Now, we might be asked, how much benzene is left over? Well, let's see, I'll use a different color here. That would be pretty simple calculation. We would take and again start with our limiting reagent. And convert not even convert, just convert grams to moles, or moles to grams here. And I'm not sure what this, let me work this out real quick, I guess. So 78.11 70.3. So that's, what is this number here? This number is how much benzene is consumed. And so the amount of excess, so the left over benzene, 72.5 minus 70.3, what is that, 2.2. So if you were asked what is left in the container, well, it would be 48.7 grams of water. We could do this calculation for carbon dioxide, but we would also have some benzene left over in the container. We would have no oxygen left over. That's the limiting reagent that would be used up, in as much as this reaction goes all the way. And combustion reactions really do, they go, the equilibrium lies way, way, way to the product side. All right, so again, very kind of simple to see and to watch me do it here, but make sure you feel really good about it and practice plenty of problems out of your Gen Chem book.